In this video, we will learn about what are the rational numbers and what are irrational numbers. So, the definition of rational number is that any number which can be written in the form P over Q, right? P over Q form mean it can be written in a fractional form, but there should be two conditions which will be fulfilled. One condition is that P and Q they belong to Z. Now this sign, if we have this sign, it means these numbers belong to something. Here it is written as P comma Q belongs to Z. So first condition is that P and Q both they belong to Z. Z means set of integers. And second condition is that the number which is in denominator, it should not be equal to 0, because if it is equal to 0, then any number divided by 0, it will give you infinity, right? This is the definition. 1 over 0 is equal to infinity. 2 over 0, it is undefined. 3 over 0, it is undefined. So second condition is that Q should not be equal to 0, right? So set of integers, what are set of integers? Integers mean they will be positive or negative. 0 is included in it. Plus minus 1, plus minus 2, plus minus 3, plus minus 4, it's going on up to plus minus infinity, right? So we have any type of numbers, whether they are positive or negative. So any number which can be written in this form, like if I will take plus 4 and plus 3, the 4 divided by 3, it is also an rational number, right? Because it can be 4 and 3, they are integers, and denominator is not equal to 0, so it's a rational number. Similarly, if I will take minus 7 or 4, again minus 7 is in set of integer, 4 is also in set of integers, and 4 is not equal to 0, so this number is also a rational number. Similarly, under root 16, you know the answer of under root 16 is, it will be plus minus 4 or plus 4 or minus 4. They belong to set of integers, right? The answer is set of integers belong to, and if we have plus 4, then plus 4 meaning 4 divided by 1. Any number, if here it is written 3, here it is written 7, so every number is divided by 1, but we will not write it. And every number is multiplied by 1. Keep it in mind that every number is divided by 1 if it is written or not, right? And every number is multiplied by 1 whether it is written or not. So keep it in mind, this thing, because these things will be very important and can be used in real numbers whenever you will study further. So 4 can be written as 4 over 1 form, because its answer is again 4, but it have taken the shape of P over Q form. P and Q belong to set of integers. 1 is not equal to 0, so this is also a rational number. Now similarly, these are rational numbers, so under 16 is a rational number. Again, further, if we will take this type of numbers, for example 4 over 3, we can simplify it further. How can we simplify it? We will divide 4 by 3. So I have divided here 4 by 3. You will check. 3 times 1 is 3. We have remainder 1. Put point here. Increase 0 here. It will be 10. 3 multiplied by 3 will give you 9. When you will solve it, it will give you 1. Again, you have put point here, so you can increase how many zeros you want. Again, multiply by 3, multiply by 3, 9. When you will solve it, again it will give you 1, and so on. This process will go on, and here you will take the answer 333, so on. So I have put here commas here, points, right? So 4 by 3, its answer is, when I will solve it, it will give me decimal fraction because it has decimal point. But in decimal fraction, in decimal answer, you will see some number is repeating itself, right? So it's a first of all, it's going on, there is no end, so this is called, it's not terminating, it's not going to finish anywhere. If you will solve in the whole life, you will solve it and it will give you 33333 answer, right? So 3 is repeating itself, it's non-terminating, it's not ending. So first answer is it's non-terminating. And second thing is that 3 is repeating itself. You can see 3 is repeating here. So 3 is reoccurring. Reoccurring mean again it's coming. So you have to remember two names: non-terminating, there is no end, and reoccurring because it's coming again and again. So this decimal fraction, its name will be non-terminating recurring decimal fraction. Recurring means reoccur, it's coming again and again, right? So this type of decimal fraction is non-terminating recurring decimal fraction, right? And the same way, I will not write 3 again and again and so on. The second way, if I want to write it, I will write it like 1.3 bar, a little bit line on the head of 3. It's called 1.3 bar. This shows that this 3 is repeating itself, non-terminating, right? It's not going to end. So second way to write it is 1.3 bar. This small line shows that 3 is occurring again and again. So this is non-terminating recurring decimal fraction. So our rational number have two types. Some are, they are terminating. For example, if I have this type of number 10 divided by 5, this is a rational number, and this rational number, when I will solve it, it will give you answer 2.02. So it's terminate, it's going to finish, nothing is recurring, nothing is coming again and again or repeat itself. So this rational number is a terminating decimal fraction, this type of fraction, right? Similarly, 24 divided by 4, when I will solve it, it will be terminate 6.0, nothing is repeating here. So this is again a terminating decimal fraction. So these type of fractions, they are terminating decimal fraction. Now I have given you one example of non-terminating recurring decimal fraction, but there are other types in which here only one number 3 is repeating itself, but in some cases you will see that set of numbers, they are repeating itself. Pi is a number which is used in mathematics a lot. Its value is 22 divided by 7. When you will divide 22 by 7, you will check here, when I divided 7 times 3 is 21, the remainder is 1 here. I put point here and then I can increase 0, whatever I want. So 7 multiplied by 1 will give you 7. 10 take away 7 will give you 3. Put point here, it will become 30. Now 7 multiplied by 4, it will give you 28. When you will subtract it, it will give you 20. Again 7 multiplied by 2, it will give you 14. You will take away, it will give you 6. It will become 60. 7 multiplied by 8, it will give you 57, right? And when you will take away, take it, you will get 4, it will become 40. And 7 times 5 is 35, right? You will go on, it will give you 50. 7 times 7 is 49, right? And after 49 you will take it away, then you will get 1 here. Again you will make it 10 and you will see 10. Again it will repeat itself, right? So after this, the same answer will repeat again and again. You will get the same set of 1 4 2 8 5 7, right? So this answer after point 1 4 2 8 5 7 will repeat itself. So a set of numbers, they are repeating itself. There is no one number or two numbers repeating itself. There is a set of numbers, right? I am underlining this set of numbers. So when the set of numbers, they are repeating itself, they are not going to end, they are not terminating anywhere, they are going and going on up to infinity, they are going. So we will write the answer 3.142857, again 1.142857, and again it will repeat itself. So how we will write this thing? We will underline, we will on the head we will write this bar on all the numbers which are repeating itself. The set of numbers 1422857 is repeating itself. So I will put bar on the head of these numbers, set of numbers. So my answer is 3 point this. This is our value of pi. So you can see that this is non-terminating. Some set of numbers, they are repeating itself, they are reoccurring. So this type of decimal fraction is called non-terminating recurring decimal fraction. So this is again a rational number, right? So this is the definition of rational number. When we will divide it, simplify it, we will get non-terminating. In some cases we will get terminating decimal fraction. It's okay, it's going to end, that's fine. So one kind is terminating decimal fraction and second kind is non-terminating decimal fraction. But in non-terminating decimal fraction there are two types. Some numbers, they are going to repeat itself, one number or set of numbers. If they are coming, then we will say this is non-terminating and recurring decimal fraction, because some number or set of numbers, they are going to repeat itself. But in some cases, when you will solve the question and you will get non-terminating decimal fraction and non-recurring decimal fraction. Non-recurring mean not a single number or set of numbers, they are repeating itself. When you are solving the numbers, you will get the random answers. There is nothing's number or set of numbers, they are repeating itself. So it's called non-recurring, non-terminating decimal fraction. And this is the definition of irrational number, right? Keep it in mind, these are irrational numbers. So this is the main difference between rational and irrational numbers. So when you will study, you will check, you will get recurring, non-terminating or terminating, non-recurring. You will have to notice which type of decimal fractions you will get, and then you will choose whether it's a rational number or an irrational number. In our book of year 11, you will see that these are rational numbers, definition of irrational number, which I have defined earlier. And then we have decimal representation of rational and irrational number. We will check there are terminating decimal fraction, which I have told you earlier. Then recurring decimal fraction. So the recurring, I have told you that one number or a set of numbers, they repeat itself. So every recurring decimal representation, that will be a rational number, I have told you earlier. But a new kind, that non-terminating, non-recurring decimal fraction, is a decimal which neither terminate nor it's a recurring. It's not possible to convert such a decimal into a common fraction, right? So if you can't convert it into a common fraction, then this non-terminating, non-recurring decimal representation will be an irrational number. So in the next page you will see that they have given lots of examples. Look, 0.25, it can be written as common fraction, 25 over 100, so it's a rational number. 1 by 3, when you will solve, you will get 0.33, so it's a recurring decimal fraction, right? But it's non-terminating, it's okay, but something is reoccurring, which is 3, so it's a rational number. 2.3, here it is written bar, it means 3 is repeating itself, one number is repeating itself, so it's again rational number. 1 by 7, again you can see a set of numbers repeating itself. Again, it's a rational number, right? But this number, you will see, it's non-terminating, but it's going to, nothing is repeating itself. The random numbers are coming when you are solving. So this is non-terminating, and non-periodic mean non-repeating itself, non-recurring. So this is an irrational number, right? You can see the difference between rational and irrational number. So here again, in next example, you will see there is not a set of numbers, random numbers repeating itself, not repeating itself, but random numbers are coming. So this is an irrational number. Again, this type of number, irrational number. These are types of irrational numbers. Again, when you will study further, you will understand which type of numbers are rational and which are irrational numbers, right? So in this video, just we have learnt about the difference between irrational number and rational numbers. In next video, we will solve next.